I greet you all once again. Those joining us for the first time, you're welcome to our class. Today, we are meant to solve this very problem. If you are conversant with most of our videos, you will notice that the last video I uploaded, we solved a similar question like this. And in that very one, the diagram seems different from this, but you see the same word, trapezium. The diagram looks in this form, okay, where we are given this very side here to be a particular number, and we are given the length of this place to be a particular what number, and here to be a particular what number, while the height here is not what given, and the angle here is what given. Okay, now we were able to solve this in our last video. So if you take a look at this, the formula we applied in solving this particular shape of trapezium can also be applied in solving this very shape of what trapezium. Okay, so the only difference here is that the height of this trapezium is not given, and this length height here is also not what given. Just like in this previous one we solved before, this length height was given. So we're able to relate that using trigonometric ratio. So how do we go about solving this one now when this length height here is not given? We're only given the two parallel what side. Okay, so let's take it one step at a time. Now, taking a look at this, if we divide this into two, okay, separating the triangle from the main part of the trapezium, we have what? We are going to be having two shapes here. We have a rectangle and a what? A triangle like this, okay? Now, by doing that, the property of a rectangle tells us that the two opposite sides are what? Equal. So that means that if from here, from P to S is 9 centimeters. Now, let's assign a letter here. Let's say here is what? E. Okay? Obviously, from Q to E will also be what? 9 centimeters. Okay? So if you subtract this 9 from this total length of QR, which is 16, okay, we are going to have what? 6. So that means from E to R will be 6 centimeters. While from Q to E will be what? 9 centimeters. Okay? So from here now, we can bring out this very section here of this triangle so that we can, by relation in trigonometric ratio, we can be able to find this very word height, the height here. That is what we are looking for. Remember vividly that the formula for calculating the area of a trapezium is given in this form, where we have half open bracket A plus B multiplied by what? Height. Where this A is the upper word parallel side, and this B is the lower word parallel side. So we can denote this as what? Our A equals to 9 centimeters, and our B is what? 15 centimeters. Okay. Then our height is what we are looking out for. Okay. Now, if we bring an extract of this triangle out here, we're going to have something of this nature. Okay. So here is the height, while the angle here is what? Is 30 what? Degrees. Okay. Now our aim is to find the value of this height. And we already know the distance from here to here to what? 6 centimeters. By subtracting 9 from 16, we got this what? 6. Okay. From 15 rather, we get this was 6. Now, what relationship binds this side and this very side? We all know the property of a right angle triangle. This is a right angle triangle. Okay. This is the longest side, known as the what? Hypotenuse. Where the angle is facing our what? Opposite, while the remaining sides are what? Adjacent. So from the very mnemonic we are familiar with in trigonometry, which we denote as SOHCAHTOA, we can simply denote and find out the relationship that binds these two words side. This side you are looking for, and this side that was given. So here is what? Opposite, and here is what? Adjacent. So from our SOHCAHTOA, I want to connect opposite and adjacent. This is so, which denotes opposite over hypotenuse. This is ka, which is adjacent over what? Hypotenuse. While this is toa, which is opposite over what? Adjacent. So this first initial in each of the name denote the word, the trig word ratio, which is this one is sine. Okay. Then this one is cosine, and this is what? Tangent. So from here now, we can apply what? Tan. Okay. This will give us what? We are going to have this as what? Tan theta equals opposite over what? Adjacent. Okay. So in that case now, we're going to have this as what? Tan 30 to be equal to what? Our opposite is what? H. Okay. All over our adjacent is what? 6. Okay. Now we are going to have this in this order. Can multiply to find all of our what? H. So 1 times 8 gives us what? H. Then we have this as what? 6 times what? Tan 30. What's the value of sine 30? So let's check our calculator. Sine 30 gave us 0.577. Okay. So that means our height will be 6 times 0.577. Okay, I'm going to leave that in 4 place of the decimal. So multiplying that by 6, we'll get to find that our height is equals to 3.464 centimeters. So that is the height of this very what? Trapezium. Okay. So now let's go back to this very formula and substitute the parameters we have been able to what? To find. Okay, since everything is now complete. So going by this formula, we have half into what? Our A is what? 9 centimeter, while our B is what? 15 centimeter. Okay, then multiply by what? Height, which is what? What we have here as 3. Let me clean this height out. Okay, so this we have this as what? 3.464 centimeter. Now taking the sum of this, 15 plus 9, so I'm going to have that as what? 24. So this is times 24 centimeter, okay? Then multiply by 3.464 centimeter. We notice that this one is common, okay? That means 2 is common to 24. 2 here, 1. 2 in 24 gives us 12 centimeter, right? So we left with 12 centimeter multiplied by 3.464 centimeter. Now, let's multiply this out, okay? Multiply by 12. We have that as 41.569, okay? So let's do it in 3 decimal place, and that will be what? Centimeter what? Squared, okay? So the final answer for this is 41.569 centimeters squared. Now, if the answer or the question states that you should give your answer in so decimal place, that will determine where or the number of decimal place your answer will be left as. Okay. But in this case, now nothing of that nature was stated in the question. We already asked to calculate the area of the trapezium. So I did this way to leave my answer in 3 decimal place. So this is our final answer for this. Would do well to follow us if you are just watching us for the first time, and you will get notified once we will make a new upload on another topic or still on this same topic. So do well to have a blessed day. Bye bye.